Let us talk about how to identify arrays in disassembly. In memory, an array of integers looks same as integers declared consecutively. At the same point, you can say that same data type consecutively declared or an array of data types looks the same when you inspect it in memory. For an example, I declare something like this: integer a equal to 1, b equal to 2, c equal to 3, d equal to 4. In memory, it looks like this. Size of an integer is equal to 4 bytes. So suppose 1 is located at mem x, then 2 would be located at mem x plus 4 bytes, while 3 located at mem x plus 8 bytes, and 4 located at mem x plus 16 bytes. Now, if I declare integer a, array of integer a, 1, 2, 3, 4. In memory, it will look very similar. Only thing, the order is order of the numbers are only changed. But you cannot clearly distinguish whether it is an array of integer or consecutive set of integers. Then how do you distinguish an array? So we can identify an array by the way they are accessed. Array are accessed in loops. Elements in array accessed with an index from the first element from the array. So programmatically, it should look like this. For index equal to 0, index less than equal to size, index plus plus, then the element in an array would be accessed like this: array in brackets index. So again, if we revisit this, how the arrays and array of integers look in memory. So here is how they look like. Integer a equal to 3, b equal to 5, c equal to 7, d equal to 9 looks like this. While array looks like this: 3, 5, 7, 9. In both the cases, you will see that they are arranged one after another. So it's hard to distinguish by just looking into the memory. Now, let us see how an array access looks like. So here is a piece of disassembly which shows the array access. Let us read it. First, if you observe the disassembly, so here is a loop, which is a backward jump. Now, if you look at the top of the disassembly, this one reduces to something like this. So a local variable is here, and in each iteration of the loop, the local dot one increments by 1, which means local dot 1 is a loop counter. Next, if you observe this, the pattern looks somewhat like this: local dot 1. So if you just read this disassembly, this one will reduce to local dot 1 star 4 plus EBP minus 24. So basically, in each iteration of the loop, 4 is always going to be a constant because it's a number, and EBP minus 24 is also going to be a constant, and EBP minus 24 is a local variable. Now, this one is array element access. If you observe the pattern, it would be like this one is the counter, and this one is a fixed number, and this one is the start of the array. So basically, if you will see an array access, it looks somewhat like this. Array element access is equal to loop counter into element size plus array start. So in this case, we have an integer elements whose size is 4, and array start in our case is EBP minus 24. So let us look into an animation how this looks like. So array start EBP minus 24 is pointing to the start of the array. So when loop counter is 1, index equal to 0, and array start plus index star size of the element, which is 4, points here. In loop 2, index equal to 1, and you can access the second element of the array. When counter is 3, index equal to 2, and you can access the third element. When loop equal to 4, counter equal to 4, then index equal to 3, and then you can access this element of the array. So this is how an array access works. And you should be able to identify array access by looking into this kind of pattern.